Kannimuthu, sir.
Good evening, sir. Tell me, sir.
Audible to everyone?
Yes, sir.
Yeah, good evening, everyone. I welcome all for FTP. Yes, Kannimuthu, Professor of Science Engineering at Katham College of Engineering, Coimbatore, and in charge of Center of Excellence in Algorithms. He is an IEEE senior member, and I am certified cybersecurity analyst over 10 years and industry. He has guided 7 PhD scholars, published 8 plus author book delivered and I leave this virtual ties to Dr. Kannimuthu sir.
Thank you,
Sir,
sir.
please take over the session, sir.
Yes, sir. Are you able to view the screen, sir? Hello, good evening, participants. This is Kannimuthu. Today, I wish to present this session in machine learning for educators, concepts and practical applications. This session agenda is to introduce about machine learning, that is basis of machine learning, and I wish to explain about the kinds of different kinds of machine learning.
It is
Are you able to view the screen, sir? Then I wish to discuss about the applications of machine learning in education field. Then I will tell how to enhance teaching effectiveness through machine learning. Finally, I end this session with hands-on demonstration. Actually, education field is rapidly transforming and progressing through digital technologies. Artificial intelligence and machine learning are the useful tools for improving the teaching pedagogy. Teachers can make use of machine learning to enhance the teaching strategies. They can introduce personalized learning, and we can automate the repetitive task. The main aim of this session is to offer the foundation in ML and demonstrate practical application for teachers. First, I start with the fundamentals of machine learning. Machine learning is kind from AI that facilitates the systems to learn from the data. It is based on data-driven approach and enhance the performance without a explicit programming, which is completely different from traditional programming. There are several key steps in machine learning process. First, we need to start from data collection methods. We need to for solving the problems. First, we need to understand it, what kind of problem that is to be solved. Then, for solving the problem, we need to collect the data. Data are of different format, which may be structured or unstructured one. After collecting the data from the sources, we need to do pre-processing, that is making the data into trainable one. So before applying the model to the data, we need to pre-process it. Then by using the machine learning model, for example, it may be a classification process or prediction process that I will tell later. We need to apply model training by using the machine learning algorithms. Then after that, we need to analyze or evaluate the performance of the algorithms by using the performance parameters, which is different task to analyze whether the applied algorithm is effective or efficient. Finally, we need to deploy the models, that is making the model into executable stage. These are the key steps involved in machine learning process. So as I said already, it is complete. Machine learning is completely different from traditional programming. In traditional programming, what you do is you supply data and program to the computer and expecting the output. But in machine learning, we supply data and output and expecting the logic. So the main intention of machine learning is to obtain the models in terms of several representation, which may be mathematical model, which may be a decision tree, and so on. So there is a difference between traditional programming and machine learning. So machine learning is not a magic. Uh, in gardening, you deal with seeds, nutrients, and the key players called gardener. Finally, your aim is to grow a plant that you can map with the machine learning. Here, algorithms are the seeds actually. In gardening, for growing a plant, you need seeds. No, in a similar way, for machine learning, the algorithm is a core part. Then here in machine learning, data is mapped with the nutrients. Actually, for growing a plant, nutrients are very important. In a similar way, for making the classification or protection, you need data. Without data, you can't do classification or protection. Then you are you are something like a gardener. You are a governor to analyze or to investigate whether the model works well or not. Finally, the outcome is programs. That is logic. Begin classification or protection. So it is not a magic. It's something like a gardening. There are several kinds of machine learning, as I said already. First one is supervisor learning. In supervisor learning, what it is, you supply input data and output data. Output data also called as evidence. And by using that, we make classification or protection. For example, forecasting the student scores by using the internal marks, internal test. Next one is unsupervised learning. In unsupervised learning, you supply only input data. By using input data, we can identify some hidden patterns. We can group the object which has similar behavior and so on. Examples, grouping the students by learning styles. Next one is reinforcement learning. Actually, in a reinforcement learning, you making the system to learn through a trial and error method. For example, the if model or agent performs well means you give reward. If it does not perform well means you give a penalty. So example is personalized tutoring system. Next one is semi-supervised and self-supervised learning, which deals with the input data with the limited labeled information. So these are the different kinds of machine learning algorithms. So basic classification between, among machine learning is supervised learning and unsupervised learning. So our deal is whether we are dealing with a continuous data or discrete data. For example, if you deal with the discrete data means we may use classification and or categorization in supervised learning. In unsupervised category, you do use clustering algorithms. If it is a continuous kind of data means you should use regression analysis. For example, in regression analysis, both input vector and output vector both are numeric value. So you need to decide whether I'm going to deal with a discrete data or continuous data. So in a unsupervised learning case for a continuous data is dimensional reduction. So higher dimensional data may be converted into lower dimensional data to improve the accuracy and so on. So to reduce the complexity of the model, we can convert the higher dimensional data into lower dimension. There is input maybe of higher dimensions if it contains unstructured data as well as images and so on. In this case, we can use dimensional detection. Example is principal common analysis, one kind of dimensional detection. So there are several kinds of machine learning algorithm came into exist in the research field. Every year, 100 algorithms are developed by, coined by the researchers. Basically, machine learning algorithm has three major components. One is representation. That is how do you represent the model in terms of, in for making the classification or prediction. How do you assess the performance of the model by using the evaluation of the model, and how to enhance the accuracy through optimization. So these are the major components that we have in ML. In terms of representation, we can how do you represent the model? Whether you are going to use rules or logic programs, or you are using the tree, represent the model in terms of tree, or you represent the model in terms of network, and so on. Sometimes the model may be represented in terms of mathematical equations. Example is linear regression. Next, you can assess the performance of the model by using the accuracy, precision, recall in terms of classification. For prediction, we may use squared error, then cost or utility, and so on. For classification, if it is a probabilistic model, means we can use likelihood, posterior probability, and so on. If it is a classification problem, means we can use entropy, margin, KL dimensions, and so on. So by using these attributes, we can assess or evaluate the performance of the model. Next, to enhance the accuracy or precision recall, we may use optimization methods. Most prominent optimization methods called combinatorial optimization, converse optimization, and constraint optimization. So combinatorial optimization mainly used in feature selection methods. Example is greedy search. Converse optimization mainly used to reduce the cost in neural network. So in neural network, multi-layer perceptron, we may try to reduce the error by adjusting the weight. So in that case, we use converse optimization. Example is gradient descent method, stochastic gradient descent method. In terms of constraint optimization, in a support vector machine, we may identify the margin, that is the hyperplan model is created by using the linear programming method. So we realize several applications of machine learning. That is in banking and finance, we use machine learning basically to identify the financial fraudulent activities by using the classification model. In banking, we can decide whether to give a credit card, debit card to the customer by using the data classification method. In agriculture, we may do yield prediction. We can identify the diseases. We can classify the diseases by using the machine learning algorithms. In medicine field, we use machine learning algorithm for diagnosis and prognosis of a disease. In computer security, we may detect the malwares and viruses. We can forecast the intruder activities by using the machine learning algorithm. So we can retain the customers. We can, enhance the customer relationship with the help of machine learning algorithms. And also we can use a machine learning algorithm for education purpose and weather forecasting and so on. So here I wish to introduce some of the concept, key areas in machine learning. First, I start with classification problem, particularly supervisor learning. I explain about neural network. Then I introduce linear regression, logistic regression, Bayesian classification methods. Then I discuss clustering algorithms. There is unsupervised algorithm and dimensional detection. So neural network here you are automatically generating the artificial neurons to identify the relationship between the input vector and output vector. So we can use neural network for classification as well as the forecasting purposes. We have a set of input data and set up target value for a neural network. And we are trying to get good prediction that match those target values as closely as possible. So if any deviations or errors happen means we do optimization method to reduce the errors. So this is the simple layout of a neural network. Here you supply the input vector, and we artificially generate a weight vector, that is artificially generated neurons. That is also called as random numbers. So input vector is multiplied with the random number, that is weight vector, to obtain the output values. These values are thresholded by using the activation functions. So which is related to the brain neurons. So it's a brain neuron. We have billions of brain neurons in the human brain. So the every action has been done in the real world by associating one neuron with another neuron only. So in real world. So in a similar way, we are mapping the brain neurons with the artificial neural network. Here, we are artificially generating the neurons, random numbers, to associate the input vector with the weight vector to obtain the actual output. So we do classification by using the maybe nonlinear classification and nonlinear classification by using the activation function. So here, if you have only one layer in between the input vector and output vector, means it will be called as a single layer perceptron. If you have more than one hidden layer to identify the nonlinear relationship between the input vector and output vector, means we can use multi-layer perceptrons, also called as deep learning. So one of the most famous model that is for a network is Maculo-Fitts neuron. We have only one hidden layer in the Maculo-Fitts neuron mathematical model. You just supply input vector and artificial generated weight vector, and you multiply input vector and weight vector to obtain the result. These results are summed up to send to the activation function. Activation function is responsible for giving the result, whether it is a zero kind of output or one kind of output. So Maculo-Fitts neurons is based on the formula that is summation of I equal to 1 to n xi wi. That is, if it is a two-dimensional data, means we can use x1 w1, x2 w2. So, and along with that, we use bias for making the system to learn. So this is the output vector. Y is output vector. You can obtain the you can generate a weight vector randomly. After that, we just multiply input vector and weight vector to obtain the expected output. So you need to decide whether you are going to learn the linear model or non-linear model. So linear model is suitable. Is best for linear regression. Perceptron, linear perceptron, singular perceptron. If you are going to do nonlinear classification, means you need to use multi-layer perceptron algorithms. So activation functions act as a thresholder. So after multiplying the input vector and output vector, you will get some values. By using the value, you need to decide whether it is zero kind of output and one kind of output by using the thresholder, that is the activation function. So activation function is used to introduce a non-linearity. There are several activation functions available. One is step activation function, mainly used in linear perceptron. And we have another activation function called sigmoid activation function. Then it is used in both linear classification as well as the non-linear classification. So this is example for multi-layer perceptron. Here we use several hidden layers. For activation purposes, we use sigmoid activation function here for thresholding purposes. So here supply input vector is multiplied with the weight vector to obtain the hidden layers, hidden output. These hidden output again thresholder by using the thresholder. Finally, you will get the output. This is mainly used for classification, nonlinear classification. So this is the example for linear output. Here you use and OR gate logic. Here we have two input, input 1 and input 2, and target value is output vector. Here both values, 0, so output will be 0. If either one of the value is 1 means output is 1. This is the example for OR gate. So if you is to understand whether this data is a linear kind of data or non-linear kind of data, we can make a plot. Here x-axis represents input vector and y-axis represent another input vector. Here, if both values are 0 means output will be 0. So I represent as plus here. If either one of the value 1 means, for example, x-axis value is 0 and y-axis value is 1. So I make a plot here. Okay, x-axis value is 0 and y-axis value is, I make a plot here. So for 1 0, x-axis is 1 and y-axis is 0. So y-axis 0 means I will have this kind of data. Both x-axis and y-axis is 1. So I have a circle here. So if I wish to make a classification means I need to identify the linear line, any linear line. So to classify 0 kind of data and 1 kind of data. So I can draw any line which may be any random line. Okay, so that should be obtained by using the weight vector, that is W1 and W2. As I said already, in mixed macrofacial layer neuron, I told weight 1, weight 2. This is a random number. We can generate random number to draw the line that separates 0 kind of data and 1 kind of data. So this is the example for linear separable problems. So I tell an example for nonlinear separable. So this is AND gate is also nonlinear separable problem. So you can draw this line. OR gate is also linear problem. Okay. But XOR problem is not a linear problem. So we can't draw any linear line to separate 0 kind of data and 1 kind of data here. So I need to use multilayer perceptron algorithm in neural network to classify non-linear kind of data. So by using kernel-based method, we can achieve this. So for non-linear classification, we do use multilayer perceptron or deep learning methods. So next algorithm is linear regression algorithm. Here I told already that in prediction problem, we supply input vector, that is input vector x and y, output vector y, both are numeric. So this is a major constraint here. So here I have taken one salary data. Here I have years of experience on is input and salary as output. Both are numeric only, no. So by using this data, I need to make a model which forecasts the salary of an employee if I give an input as a years of experience. So for that, I need to check whether it is a linear model or not. So I just plot input data and output data. Here X is a years of experience and Y is a salary. Here what I do is I need to draw the optimal line. So here for this data, when years of experience 3 means salary will be $3,000. So I make a dot here. In a similar way, for 87 experience, I have 57 here. So in a similar way, I can draw all the data. So these data are plotted here. So you can directly observe that this is a linear problem. So when x-axis increases means y-axis also increases. So sometimes non-linearity may be introduced based on the data nature. In this case, we need to use kernel-based method. Non-linear regression we can use. Here, this is the example for linear regression. Here, what you do is you just draw the optimal line such that the distance between the line that you drawn and actual data should be minimized. Sum of the squared difference between the actual data and the expected data should be close to 0. So this is the concept behind the linear regression. So for the course, we are using the least square optimization method, least square LSA method, the least square optimization, least square optimization method. So here I am in a position to draw the optimal such that the sum of the squared difference between the actual output and expected output should be minimized to 0. So why I am using some square here means, so I can use y minus y dash. Why I use square means, sometimes, for example, I draw the line and I found a error as 2. Next, I draw the another difference and I found a error as 2. So first one is minus 2, second one is 2. When I sum up the square, errors means we will get 0. But we have an error here. Here we have minus 2, here I have 2. When I sum up the error, I will get 0. Your model says that you have no error if I use y minus y dash. This is not a cost, it is not actual cost function, which failed to cover the error, identify the error. So if I use squared error means I can able to figure out the errors. For example, if I use squared error means I can square the errors, minus 2 squared plus 2 squared. So I will get 4, no? So by using the square error method, I can easily identify the cost or error that has to be reduced. So for error detection, we can use regularization method. So we can use L1 regularization and L2 regularization to adjust the model to reduce the error. This is the example for prediction. So if it is a two-dimensional array means we can easily identify figure out the data. If it is a multi-dimensional data means we need to identify the hyperplan which is best forecast the model. Next one is Bayesian classification. Bayesian classification is an example for probabilistic model which involves Bayesian theorem. Here we have hypothesis, that is outcome, and input vector. So probability of hypothesis divided by given x equal to probability of x given h into p of probability of hypothesis divided by probability of x. So these are the example for posterior probability. This is the example for prior probability. So by using the Bayesian theorem, we can make a classification. So P of H given X is the posterior probability. There is H contingent on X. For example, suppose you have a data that is confined to the customer described by the attribute age and income. So we have a input vector age and income, and we have a data that X is a 35-year-old customer with an income of 40,000. So, we need to identify, person who is able to buy a computer if they have this kind of age and income, particular income. So by using the classification, this kind of classification, we can make a classification by using the input vector as well as the hypothesis. So probability of H given X means that it reflects the probability that a customer X will buy a computer given that we know the customer age and the income. So already we have a evidence. So if customer have particular age and income, they are able to buy a computer or not. So probability of H given X reflects the probability that customer X will buy a computer. So here P of H is a prior probability. In prior probability, is a probability that any given customer will buy a computer. So any customer will buy a computer. This detail is available in the probability of H, which does not care about the age, income, or any other information for that matter. And probability of X given H is a posterior probability of X conditioned on X. That is, it is a probability that a customer X is 30 years old and earns 40,000. Given that we know the customer will buy a computer. Finally, Phi of x is a prior probability of x. That is, in our example, it is the probability that a person from our set of customer is 35 years old and earns 40,000. So by using this, we can make a classification. So we need to identify H condition and X in a Bayesian theorem. Next one is decision tree algorithm. In decision algorithm, we supply both the numeric value and discrete value. The output vector will be the discrete value. Like this, here I have both in numeric value and discrete value as input, and output will be the discrete value. So by using that, I can make a classification. Here in decision tree classification, output will be the decision tree. I mean binary tree. It makes use of greedy strategy to make a classification. Here we need to, for making the decision tree, we need to use a attribute selection method. There are attribute selection, several attribute selection methods available. First one is information gain, and another one is Gini index. Finally, last one is gain ratio. So by these methods, we can choose the best attribute to make a classification, data classification. So next one is K nearest neighbor algorithm. So K nearest neighbor algorithm is mainly used to make a classification. Here we use data, both numeric value and discrete value, and output will be the discrete value. I will give an analogy for this model, this kind of model. Suppose you are in a nightclub and decide to dance. It is unlikely that you know that the dance moves for the particular song that is playing. So you will probably try to work out what to do by looking at what other people close to you are doing. So by seeing the other people that they dance, by using that we can make a dance. Even if you don't know the dance steps. The first thing you could do would be just to pick the person that is closest to you and copy them. So this is the analogy. However, since most of the people who are in the nightclub are also unlikely to know all the moves, you may decide to look at few more people and what to do most of them are doing. This is the pretty much exactly the idea behind the nearest neighbor method. If you don't have a model that describes the data, then the best thing to look at similar data and choose to be in the same class with them. So by using the KNN, we can make a data classification. Okay, basically, it identify the, for example, if I have a input vector and that I want to classify whether 0 kind of data or 1 kind of data. So I just take a input data and compare with the trained data. Already existing data, that is historical data, by using the distance-based method. So by using the distance method, we can identify the distances of all the input data, that is historical data. Among that, I can pick the closest data. By using that, I can classify whether it's a 0 kind of data or 1 kind of data by using the majority voting. So I can use Euclidean method, Manhattan method, and Minkowski distances. So here, I saw an example how to perform distance, identify the distances. Euclidean distance is a one kind of distance-based method, famous, prominently used method. Other methods called Manhattan and Minkowski are rarely used. Here, I have an input vector, height, weight, and t set as a discrete value, output vector. So I can, I wish to identify the distance between the that is model that you wish to classify. Here I have historic information, height and weight, and t-set sizes. Now I am in a position to choose the t-set size for the input vector 161 and 61. To achieve that, I can identify the distance between these historic information and the test data. So for example, I take 158. Here I consider I use a distance-based method called the equivalent distance. 158 minus 161 whole square Apply square root. Distance makes use of square root. No, see here. Next, I take another vector, 61 minus 58. Okay, so I will get value 3 square plus 3 square. So, square root of square root of 18 is 4.2. So in this similar way, I can identify the distance measures for all the data. Here, I consider k value as k in k nested, you need to choose the k value. K value as 5. Okay. So I take distance values which are of less. Okay. I take 5 distance value which are of closest to the input data. So I identified 5 values, that is 1.4, 2.2, 2.2, 2.0, and 3.2. Out of these 5 classes, I identified 4 or M. That is, by using the majority voting, maximum M will be coming. So I make classification as M for this example. So this is the one example for KNN classification. Very easy actually. It is also called as lazy learner. In previous models, use up for making the classification or prediction, you already trained the model. By using the test data, we can easily identify, make a classification. But in KNN, you are not trained, you are building the model, existing model. Okay. So whenever you investigate the data, test data, then only you are making the training and identifying the whether it is a belonging to the medium case or large case. So it is also called as, so that is why it is called lazy learner. Next one is unsupervised learning. Example for unsupervised learning. For unsupervised learning, mainly used for grouping the object which has similar behavior. Here I have one medical example. Here I have weight vector and cholesterol value and gender value. Here I supply only input vector. By using that, I can group the person who have particular behavior. For example, I can group the people who is having the high risk of cardiac disease, etc., by using the k-means algorithm, k-means, k-mediates algorithm, and so on. So here I have 3 groups. If I use k-means algorithm, one is high weight, high cholesterol, another one is medium weight, medium cholesterol, another one is low weight, low cholesterol. So we can focus on high weight, high cholesterol person who is having high risk of cardiac disease. So this is another example. Next one is principal common analysis. Mainly we use principal common analysis to reduce the dimensions. If you have large dimensions of data and you are trying to make the data classification or prediction, means sometimes you may get less accuracy because of you are supplying the irrelevant data, noisy data to the model. To avoid that, we can apply numerical, dimensional reduction methods such as principal common analysis, LDA, to reduce the dimension and enhance the accuracy of the model. Now, I am in a position to explain the applications of machine learning in education. Mainly, we can use education field in terms of personalized learning. We can do dynamic content delivery based on the student performance by using the machine learning algorithms. So we can use models whether to analyze the behavior of the student or student performance by using the historic information and do the personalized learning. Based on the performance, we can change the teaching activities and we can use machine learning for automatic grading. Nowadays, many institutions doing the automatic grading. They are inputting the test papers, hard copy of the test paper to the system. It will be scanned and submitted to the machine learning model. Machine learning model automatically um, uh, that is valuing the paper and giving the grades and so on. And we can also make use of machine learning to predict the early dropouts. So they analyze the behavior, attitudes, and all. By using that, we can forecast the early dropouts, and we can make use of chatbots, virtual tutors for intelligent tutoring system. Mm, I mean, ChatGPT is example for intelligent tutoring system. It is used to solve several problems. Sometimes it may not accurate, so you need to prompt correctly to get accurate output. Next one is we can use machine learning algorithm for content recommendation, suggesting learning resources similar to Netflix recommendations. Nowadays, Coursera makes use of content recommendations. They recommend the courses, what courses can be taken after completing the particular course. And also we can use machine learning algorithm for research support. So by using it is ChatGPT and DeepSeek, we can use tools, AI tools for writing the papers and making the research and so on. So, so we can enhance the teaching effectiveness through machine learning algorithms also. By using the real-time learning analytics dashboards, we can achieve that. And we can identify the individual student needs and gaps by using the machine learning algorithm. We can provide the feedback, personalized feedback dynamically by using the machine learning algorithms. We can enhance the engagement, student engagements through AI-forward simulations and gamifications. So we can reduce administrative task that is pertaining to the teachers and the faculty members focus on creativity and mentoring now. Now I just give a hands-on for what are the tools that you can use for enhancing the teaching. One is a Google Teachable Machine. That is, we can build the model without coding by using the Google Teachable Machine, I wish to tell. And another one is for research purpose, we can use visual machine learning platforms, mainly is useful for beginners. Then we have one facility that is LLM facilities available in Jupyter Notebook. We can create models. If you don't know, even if you don't know the machine learning programming and coding and all, and we can use plugins. For example, in Moodle, we have AI plugins, which will be useful to provide the grades, and we can recommend the content, courses, and so on. That is AI-enabled LMS, which is open source only. We can make use. We can install in our institution, and with the AI plugins, AI will take care of grading the assignments, and they suggest courses that you can take after completing the particular course and so on. And also we can make use of ChatGPT and AI assistants for content generation and the student support. So to get several answers in terms of basic fundamental learning as well as research and so on. Now I will tell about Google Teachable Machine. So just in Google, just type Google Teachable Machine. It is not installable. Just you can directly use. It is available in website. Click Google Teachable Machine. You can start. So here I wish to train the model. So you can take any kind of project, image project, audio project, and post project. No need to code it. Just click the project. I just Susan image project. So I just use standard image model. Okay. So I used two kind of classes. This is example for binary classification. So whether I'm happy face or not happy face. So I can classify whether I'm happy or not by using the Google Teachable Machine. So first I take trainable example for happy, not happy, and happy. Okay. First I click, I can rename it, not happy. Another process, happy. So now I'm going to train without coding. See here. Wait a minute. The video is already used by the Zoom, so I just now I try. I have trained not happy face, and I am going to train happy face. I have trained not happy face. At least several phases. See here, I have trained data. Temporarily, I have suspended Zoom video because it is used by the teachable machine. So I have not happy face, and here I have happy face. Now I'm going to train the model without coding. See here, it's making training. Now it is trained. See here. So now I'm going to disable the Zoom video to check classify whether it is a happy or not happy. I'm smiling, so it is happy. So I can make a classification. So in terms of if I'm happy means percentage will be high for happy. So this kind of tools can be used for the uh, ML classes. So we can impart this machine learning concept to the students for data classification problems and all. So we can make use of teachable machine for machine learning tasks without coding. So this is one example I wish to show. We can try this method, teachable method. Okay. Now I'm going to explain another tool. That is Vika. Vika tool. Vika tool is a open source machine learning tool, which is highly used for researchers and students to train the models. Here, this tool is developed by using the Java programming language. So you have several options here. I just wanted to explain Explorer. See here, without coding, we do analysis. I mean, data classification and that. Here, first thing is you need to, it has several tasks. That is, it follows the machine learning process. Here, I'm just opening the data file. Data file is available in the install directory itself that you can find in program files. It's not available here. Here I have Vika installed file. In that I have data folder. I just select fresh cancer data set. Yeah, just open data set. Here we have input vector and class label. The age, menopause, detail, tumor size, and so on. Several input vectors available, and final class, whether it is a tumor, it is a cancer tumor or not. There's information also available there. Non-recurrence event, recurrence events. So we can visualize the attributes by selecting it. See here, what are the possible values that you have here. And after selecting the data set, we can go to classify tab and click choose option. Here we have several algorithm which is already implemented. Here I have selected a decision tree algorithm which is available as a name J48. Okay, I just selected. Now I can apply percentage split option. So here I need to divide the data set into two part. One is training part and testing part. In training part, I need to supply 80% of data. The remaining data will be considered as a testing data. So by using the training data, we can build the model. By using the testing data, we can evaluate the performance of the model. Now I click start button. Automatically, you have decision trees. Now we can identify the precision, accuracy, recall, other methods also. Okay, see here. And we can visualize the tree by right-clicking the model. Just click visualize tree. So we can visualize the how decision tree. This is one kind of model represent how decision tree is developed. I mean built. So this is another example for educators to teach the machine learning in the classrooms. And also anyone can be easily familiarized with machine learning models if you use these kind of tools. So we can build the model without coding. If you have data, we can do data pre-processing, data classification, clustering, and so on. Okay. This is another example that I wish to. Okay. Next one is that I want to see is Jupyter Notebook. So I just wanted to show the Google Colab. There is a online Jupyter Notebook only. Here we have Gemini LLM model. Okay. Use Gemini LLM model for building the models. See here I have clicked a new notebook. Automatically will be opened. Here you can have an option called generate with the AI. Just click generate with the AI. So it will ask whether what I can do. So I just tell the information. Build the classification model using the generated data. Just I given the information, just prompting it. Automatically it will work on the model building. So it will show the steps, what are the steps he is supposed to, the model supposed to do. So here it will give the input data and see here, accept run. I'm just clicking accept and run. We'll get, sometimes we will get result. Here data is not defined, so it is working actually. But automatically it is generated the data. Then you get the code, and after running this you can run this one. Now you are getting the result now. After generating the data, you will get the result. If you wish to increase accuracy, you can try to generate another data. So by using the LLM tools, that is like Gemini, we can build the model without writing the code. I didn't write any code. I didn't import anything. Automatically, these tools, I mean LLM tools, helped me to generate the data and making the classification and all. So these are the things that are happening now. So we can, I think you know about the chat GPT, about that is how to write the research papers and all. So yesterday also is mentioned by the another researcher. So thank you for the opportunity to give instructive session about the applications of machine learning for the educator. If you have any queries, you can raise now, or you can contact me through email and phone number. Thank you. Thank you for the opportunity.
Sir, sir, please stay tuned, sir. Stay tuned.
If you have any queries, you can raise.
Is it audible now? Is it audible, sir?
Yes, sir. Yes, sir.
If anyone wants to ask question, if you have any queries, you can ask. If anyone is having any queries, you can ask Dr. Kannimuthu, sir. Sir Kannimuthu, sir, is it audible, sir? My voice is audible to you?
Yes, sir. Yes, sir. Yes, sir. Audible, sir.
Fine. Can conclude the session. So, on behalf of our Think Scholar Publishing and organizing team, I extend my heartfelt thanks to Dr. S. Kannimuthu for taking time for his busy schedule to join us on the fifth day of our FTP and deliver such an insightful and engaging session. Your expertise in AI, machine learning, and algorithms has truly enriched today's program and provided our participants with valuable knowledge and inspiration. We deeply appreciate your contribution and look forward to future collaborations. Thank you once again, sir, for making.
Thank you so much, sir. Thank you for the opportunity.
Host. host can terminate the meeting.